Now we're into the heart of Numipulator, which is all the boxes concerned with calculation and manipulation and analysis. So these boxes are normally in rows. As you can see here, from A down to Z, and these are all of different types, and the functions associated with each one are related. They'll have the same inputs and the same type of output. So we'll go back to the beginning and then look at the number operations. Number operations are probably familiar to most people. They include functions such as add, subtract, divide, percentage, sort of things you'd find on a calculator. So each of these has two inputs and one output, both in all cases numbers. So I put in here 23 and I put in here 46, and I press the equals button, I get the answer 69. The functions you see displayed here, add, subtract through to percentage, are not the only ones that you have available to you. You can always click on one of these. It's a drop-down menu. Unfortunately, you can't see this on the video because it's treated as a separate window. But if I click on that, I can now choose a different one, such as random integer A to B, and that means I can now generate a random number between, let's say, 3 and 10, and when I press the equals button I should get a number in that range. There we are. If you're not sure what one of the functions means when you look at it, you can always click on the number operation box at the top, and there you will see a list of all the functions available and what they mean. I will close that up again and we'll go back to it. I'm just going to show you the functions for number operation again, and you'll notice that quite a few of them, such as these here, have 1 0 in them. And what that means is that if A is less than B, in this case, the answer will be 1, otherwise it'll be 0. So it's a bit like true or false. By the way, before I close this, I could choose to open it, in which case it will open as a separate window. I'm not going to do that now because you won't see it. So I'll close it. And we'll just carry on looking at these number operations. Each of these boxes has a different reference name at the bottom right, next to the output field. So we've got A1 here, we've got A2, right through to A5. Now these are used to refer to the output value of the box in the input of another box. If you're familiar with spreadsheets, you'll find this similar to the use of reference names such as A1 or C2 to specify the value of the cell to be used in another cell. In Numipulator, they're used in a similar way. So we can specify that the result of A3 should be twice the value of A1 by entering A1 in the first field, putting the value 2 in the second field, and then if we press equals, we will see that we get the answer 138. Let's continue to link together a few more of these boxes. So let's say that A2 is going to be the value of A1 subtract 30, and that A5, we'll select multiply, is going to be A2 times A4. And we'll press equals, and we get those answers. Notice that we did get a different value of the random integer between 3 and 10 that time. Now suppose I want to compare two numbers. I haven't got any boxes left in the number operations row. I've used all 5 up, so I can always add another set of 5 like that. And let's say we want to compare A5 to A3, and we'll say is A5 greater than A3. So we'll do check here and press equals. And in this case we get 0. Let's try it again, and this time we get 1, and that's because the value of A4 is changing because it's a random number. So now A5 has changed in value. Normally a program will consist of many boxes linked up in this way. Now let's move on to the next row, row B, which are number functions. You can see some of them visible here: square, square root, changing the sign, increment, just a plus 1, and then you get all the trigonometric functions such as sines and cosines. We'll just have a brief look at those and go down and look at them, and again you will see 1, 0 checks, so we can check whether a number is an integer, prime, odd or even, or just whether it's greater or equal to 0, for example. Close that up again. We haven't stated this explicitly yet, but all the boxes handle only numbers. The inputs must be either numbers as usually represented, for example number 2, 3.6 or -4, or else text that represents a number. We've already seen the use of the reference names to represent numbers, but there are also some built-in words or letters that represent numbers. One of these is pi, so I can put pi in here. I can say I want to multiply that. I'm going to put 4 in here to be the square of 4. So I can put in B1 here, press equals, and we will get there that 50.265, etc. is the area of a circle of radius 4, pi r squared. I'd just like to show a few other features of the system. And now at the bottom of each box you'll see a field, and that is for putting a note or a description. So here I might put that this is radius, that's what it represents, and that this represents area. I won't put any others on because those other boxes don't have any real meaning. Now what I can do then is also to look at the details of a particular box after a calculation. So if I click on that, you'll now see that it's got no dependencies. It doesn't go anywhere else, but you can see that A equals pi, which evaluates to that. B1 is the other field, the other input, and that evaluates to 16, and that the operation we've carried out is multiply, and that gives us the answer 50.26, etc. We can also press the values button over here on the left, and that gives the same sort of information but for the whole of the calculation, for the whole of the program. So we can see what's happening with A1, A2, and this tends to be more in a bottom-up way, so things that don't depend on anything are at the beginning, and then those that are dependent on other things are right at the end. And one other feature is that we can press the flow button, and that shows the dependencies of each of the boxes. So we can see that A6 depends on A5 and also A3, A5 depends on A2 and A4, and so on. And if we have put notes in, as we have here, you get that, and you can see what the notes are, so that you know something about what those boxes mean. So far we've looked only at simple numbers, boxes where numbers are inputs and numbers are outputs, but it can also handle lists of numbers. So before looking at row C, let's just scroll down, which is about taking a list and producing a number as output. You'll see there is something called common number and common list. Now these are really intended for putting your data in, data that you expect to use several times. D is for simple numbers and E is for lists of numbers. Before entering some data in rows D and E, I'll first of all just clear out the data we put into A and B. I'm just being prompted to say that I wish to go ahead with that. And now we'll enter some numbers in here. So I'll put in 14 as the value for D1. And suppose I want to put in just the values 10, 11 and 12 as my list of numbers. How do I do that? Well, the way you might enter a list of numbers is sometimes like that. You might put 10, 11, 12. You might think of doing it that way, 10, 11, 12, using spaces to separate the numbers. Or you might put 10, 11, 12. All those are valid ways of entering a list. Now you might notice that in rows D and E, the boxes don't have a drop-down list of functions and they don't have a result field. That's because whatever you enter as your input, that value will be the output of that box. It's worth noting that you can also copy a whole table or worksheet of numbers out of something like Excel and put it into a single field of Numipulator. So I've just done that. I've copied a table. I can paste it in there. Now you can only see a few of the numbers here, but I can just spread that out and you can see that we've got a whole large table of numbers sitting in there. Now what I can do here is I'm just going to reload Numipulator, and it brings my fields back to their standard size. And also I should point out that whatever we had there in the boxes still remains there. It's all saved into local storage and then gets recovered when you open Numipulator again, which is effectively what I did then. I'd just like to show a little bit more about the way we represent a list of numbers. So this time I'm going to do something that looks a bit odd. I'm going to enter the numbers as 2, 3, semicolon, space, 5, put a return in, E1, colon, 7, might as well put a carriage return, D1, so that's a list, 15 or 19, 5 and 7. So in fact, with Numipulator, commas, semicolons, colons, spaces, carriage returns, tabs are all treated as valid number separators. But what is the value of the list that we've specified here? Well, in all cases, the value of any box that you refer to is simply inserted in its given position to produce the value of the input. So E5 here will have the value 2, 3, 5. Then E1 is 10, 11, 12. Then it will be 7. And then D1 is 14, 19, 5, 7. So that will be the value of E5. We can see this value by pressing the equals button. We know there's no result shown, but we can see the value by clicking on the I button, the information button, and you can see there that it specifies that it's been defined as that, which evaluates to that. Let's just close this window, go back to E5, and remind ourselves that this list of numbers includes not only simple numbers, but a reference name to a list and a reference name to a common number. So can we also use a reference to a list as an input to a number? Let's try it out. And of course the answer is yes. So if I put up here E5, and I press equals, I get the answer 4. And that's because a list input is treated as just the first or only number of that list. So you may remember that E5 began with a 2, so it treats it just as if I've entered the value 2. The ability to specify a list as a number input is important, because it means that if a box produces a list output that contains only one number, this can be treated everywhere as if it is a simple number. Let's close this and go down so that we can see rows C and E, and look at row C, which is concerned with taking a list of numbers and producing a number as output. So here we've got sum of list values is the selected function. So if we put in here 3, 4, 5, press the equals button, then we get the answer 12. Now let's just change the functions of the remaining 4 in that row. Change this one to be maximum value. Change this one to be minimum value. And change this one to be the first item on the list. And then for each of these, put in E5 as the input. And then when we press equals, we will see those values. Let's just add another row of boxes to C. And this time let's choose the length of the list. Again, put in E5 and press equals, and we will see how many items are in that list, 11. Now let's just go up to the top and press the functions, and we can move down to see which ones are available for list C, list function to number. And we'll see there's quite a few statistical functions in there as well, if that's something that interests you. I'll close that. Let's move on now to row G, list generation. Now the functions in this are all concerned with generating a list of values based on sets of parameters, one or more sets of parameters. Now sometimes there'll be 2, sometimes 3 parameters. You can see here P1 items of value P2, so there are 2 parameters in that case. There are 3 parameters over here. So let's put in some values here. So if I put in 33, 41 and 35 and press equals, I will get 33s followed by 41s followed by 35s. Note that these parameters are just a list, and we could have used any of our separators. I've chosen to separate the different sets of parameters out onto 3 different lines. Now, let's now go to G2, and it says integers P1 to P2. So if I put in here 1 and then 100, 1,000, let's put 1,000 in, then that should give us integers from 1 to 1,000 when we press equals. And that indeed is what we get. If we go right down to the bottom, we will eventually get down to 1,000. These functions are also useful for generating random numbers. So I could say generate P1 random integers from 1 to P2. So if I say here that I want 100 numbers from 1 to 20 and press that, that's what I will get. If we move on to row H, we find boxes of type list function to list. Again, these boxes have a single list as input, but a list as output rather than a number. Let's use E5 as our input list for all these boxes, H1 to H5. So I'm just putting that in now. And then we'll press the equals button and see what we get. It should be fairly straightforward. Equals. So in the first case, the numbers from E5 are sorted in ascending order, the next are in descending order, then they're reversed. Then we remove duplicates because we had a couple of 5s and a couple of 7s, so one of each will have been removed. And then in the last one, we've removed the first number from it. It began with a 2, so now it begins with 3. I've just come up now and I've changed the specification of E5 to be a list with just the number 3 on it. And if I press the equals now and go and look at the results of H1 through to H5, we'll see that the first 4 now just have the single list 3, because when you sort them or reverse them or remove the duplicates, you're still left with the same list. But the odd one is the last one, because if we remove the first item on the list, the number 3, we're left with an empty list. And so the result you see there, L0, is the way we represent an empty list in Numipulator. It stands for a list of length 0. This can also be used as an input to a Numipulation input field. So if an empty list can be an input to a Numipulation box, let's see what happens if we put L0 in here and press equals. We can now go down and see that the first 4 of H1 H through to H4, they're okay. The reverse is still an empty list. If we remove the duplicates, it's still an empty list. But if we try to look at all but the first, we can't do that because there isn't a first. So actually we have an error here. So the result is undefined. And if we go up to row C, we'll see some similar problems there. So we've got the length of the list of E5 is 0, which is fine. It's an empty list, so it's got no items in it. But maximum value, minimum value, and first item are all undefined because there isn't a first item, for example. And the average comes out as not a number, NaN. That's because we're trying to divide the sum of the list, which is 0, divided by 0. And 0 divided by 0 is a bit of a no-no. So when you're programming, you'll need to avoid getting such results, as if you pass an error as a value to another input, this will automatically have an error output. We'll move on to row J now. The first input, LA, is the main list on which the operation takes place. The second input is a set of parameters P1, P2 and so on, very much like row G, and the results for each set of parameters follow on from each other in the overall result. So if we make LA 2, 4, 6, 8, 12, 16, and we put in the parameters as 1, 3, 5, and leave the function as item P1 and press equals, we get the fact that 2 is the first item, the third item is 6, and the fifth item is 12. So that's our result there, 2, 6, 12. If we change the selected function to be first position of P1, and we change the parameters to be 8 and 9 and press equals, then we get the answer 4, 0. That's because 8 is the fourth item on the list and 9 is not on the list, so 0 is given as a default answer. If we now change the function selected here to be list items P1 to P2, and we change the parameters to be 2, 4, in other words, we're asking for the items from 2 to 4 and press equals, that's what we get. We get items 4, 6 and 8. There are no others. There are many more rows to look at, but two rows in particular, V and W, build on rows A and B and introduce a concept that is important in Numipulator, so we'll look at these first. So we'll move down to rows V and W, and you'll see that the items operations in row V have the same functions as in row A. So add, subtract, multiply and divide. The difference is that this operates onto lists rather than onto numbers and produces a list as an output. The basic idea is that the operation is applied to the corresponding items of the first and second input lists. So if the first is 2, 4, 6, 8, and the second is 3, 4, 5 and 6, and we select multiply and press equals, then we get the answers 6, 2 3s are 6, 4 4s 16, 6 5s are 30 and so on, 8 6s are 48. Well, that's the simple case when both lists are the same length. But what if they're not? Well, the principles are that the length of the result list will be the same as the length of the first input list, and the items on the second list are cycled or recycled to give any missing items. So if I change this second list here to have just a single item 3 on it and press the equals, then I get the answer 6, 12, 18, 24, which is 3 times each of 2, 4, 6, 8. Now you might notice that before doing that, I'd changed the output settings so that they come out horizontally rather than vertically, as I was unable to see all the items in the list without scrolling. So what I mean by recycling the items or cycling them is that the answer we get here is exactly the same as if we recycled or used again all that same input and pressed equals, we get that answer. So likewise, if I change the second list to be 3, 4 and press equals, then the answer I get is 6, 16, 18, 32. So 3 2s are 6, 4 4s are 16, 3 6s are 18, 4 8s are 32. Exactly the same as if I put in and pressed equals. If the second list has more items in it than the first, then any surplus items are just ignored. Like that, no change. With row W items function, we don't have these sort of complexities, and the result list is simply the result of applying the function to each number in turn. So for example, if the input is 3, 4, 5, 6, and the function selected is square, we'll get the squares of all those numbers.